So to review, we now have multiple tests for local maxes and mins and also for absolute maxes and mins. So for absolute maxes and mins, we have the extreme value theorem if you're on a closed interval. If you're on a closed interval, then you're guaranteed you have to have an absolute max and min, and it has to occur at either the critical points or the endpoints. So all you do is you plug all these values into the original function f. The biggest is your max, the smallest is your min. Biggest y value, smallest y value. We do have a new test here that we can do now that we know how to find local maxes and mins. This is the one local extremum gives absolute extremum test. Well, that's a really long name. But basically, what if you're looking for an absolute extremum and you have an open interval? Well, in general, we have no way of knowing if you have any at all. But it turns out that if you have only one critical point in this interval, then if you can just show that it's a local max, it'll also be an absolute max. And if you can show that it's a local min, it'll be an absolute min. And this should make sense because if you have only one critical point, then your graph likely looks something like this. If you had more things, you'd have more critical points. Now we also have properties and things that we can say now from the first derivative and from the second derivative. When the first derivative is positive, that means f is increasing. When the first derivative is negative, that means f is decreasing. If the first derivative is 0 or undefined, we call that a critical point, and it might be a local max or min, but you have to use the first or second derivative test to figure that out. The second derivative gives us information about concavity, but it also gives us information about the increasing and decreasing nature of f prime. So when the second derivative is positive, we know that f is concave up, but we also know that that means that f prime is increasing. And if the second derivative is negative, we know that f is concave down, but we also know that f prime is decreasing. When the second derivative is 0 or undefined, x is an inflection point if f double prime changes sign and f of x is defined at that point x. And then lastly, our two tests for local maxes and mins are the first derivative test, where we make a first derivative number line, we put all the critical points on the number line, we plug in points into f prime in these intervals, and then if it goes from plus to minus, you have a local max, and if it goes from minus to plus, you have a local min. If it doesn't change signs, then you have neither a max or a min. And the second derivative test, which just says you take your critical point where f prime is 0, this one only works for f prime being 0, not for f prime being undefined. You plug that into f double prime, assuming it exists, and if you get a negative number, you have a local max, and if you get a positive number, you get a local min.